Hello everybody. So today we're going to follow up our work on spheres by learning about a separate shape called a hemisphere. Now, by looking at the name, you might think this is kind of related to a sphere, and it is. Hemisphere just means half of a sphere. So we can see this in the diagram down here on the left hand side. This is a sphere that is just being cut in half along the center. If we look in our log tables, there's no actual formula provided specifically for a hemisphere, so we need to be a little bit more creative here and come up with our own formula. So because it's so closely related to a sphere, a good place to start would be to look at the formula given to us for a regular sphere. So this image on the right hand side is what we will see in our log tables if we look at a sphere. Now remember that a hemisphere is half a sphere. So a hemisphere is going to have half the volume of a sphere and half the curved surface area. So if we look at the formula here given for volume, it's 4 over 3 pi r squared. So to get the volume of a hemisphere, we're going to half that. So it's going to be half of 4 over 3 pi r squared. If we multiply these two fractions out, we will end up with top by top, bottom by bottom, 4 over 6 pi r squared, which simplifies to 2 over 3 pi r squared. Now when you're doing a question on a hemisphere, you can use the formula first of all and change it so you get a half, or you can find the volume of a sphere and then just half it at the end. So it's up to you which of those you feel more comfortable using as your method in the actual leaving cert. We'll have a look now at the formula for our surface area. The surface area becomes a little bit more complicated because the surface area for a sphere is 4 pi r squared. If we half this, then we will get half the surface area of a sphere, but it will not include the new flat surface we've created on top of the hemisphere here. So what we end up with is two different formula, one for the curved surface area, which is the outside section of the sphere, and one for the total surface area, which encompasses the flat side here as well. So if we look at the curved surface area, that's going to be half of the total area of a sphere. So it'll be a half of 4 pi r squared. When we multiply half by 4, this simplifies to 2 pi r squared. So this is our formula for the curved surface area. If you want to pause the video for a minute, you might think we'd add on the area of the flat circular surface too. When you're ready, press play. So, if you were engaging with that, what you might have remembered, if you were lucky, is that the area of a circle is pi r squared. So what we're going to do is we're going to add the flat surface, or circle, which is pi r squared, plus the curved surface area, which is 2 pi r squared. Again, we're adding the flat circular section, pi r squared, plus the curved surface area, which is 2 pi r squared. Because we have two terms here and the variables are actually exactly the same, both of them deal with pi r squared, we can add these two terms to make life a little easier. So pi r squared plus 2 pi r squared will give us a total of 3 pi r squared. So this is our final formula for total surface area. If you are more comfortable calculating the curved surface area and the flat circular surface area separately, then adding at the end, that's also completely fine. These formulas are formulas you're going to have to remember or else make up on the day in the exam using your log tables. So whatever you feel is going to work best for you to be able to use them on the day, that's the method you should go with yourself. So now we'll have a look at solving a question that uses the concept of a hemisphere. This question reads, the hemisphere below has a curved surface area of 32 pi meters squared. Find its radius and hence its volume. Give your answer in terms of pi. So there's a couple things here that stand out to me. Before we get into it though, I just want to point out that this lettering here, pi, is the same thing as the Greek letter pi. It's just the app I'm using doesn't allow me to type in the Greek alphabet. So back to the main things that just stand out to us from this question. One of them is that we're actually being asked for two things. That's the first thing that stands out to me. Being asked to find the radius and also the volume. So it's important that we make a quick note of this so that we don't forget once we're done that we have to answer a second part of the question. The second thing that jumps out at me here is that they tell us the curved surface area. So it's always important with some of these shapes to distinguish between the curved surface area and the total surface area, just so we don't use the wrong formula. So now we can try and get going at solving this question. So the first thing that we want to do is identify the shape. We're going to use the same four-step method we've always used before. So our shape here is a hemisphere. Step 2 then is to write down the correct formula that we think we're going to need. Straight off the bat, they give us the curved surface area and they ask us for the radius. So the formula that's going to have curved surface area and radius in there is going to be the formula for the curved surface area. So our curved surface area is equal to 2 pi r squared. Step 3 is where we're going to start filling in what we know. So we know that the curved surface area is 32 pi. On the right hand side, we actually don't know anything else there yet. We know that 2 is 2, it's a constant. We know that pi doesn't need to be subbed in because we're being asked to give our answer in terms of pi. And we know the radius is an unknown. So we actually can't do that because that's what we're trying to solve for here. Step 4 now tells us that we should start trying to simplify this to get to our final answer where we can solve for or. So one thing that jumps out at me that we can simplify from both sides is our letter pi. So we can cancel out pi from both sides because it's common to every term. This will leave us with 32 is equal to 2 or squared. We want to find or by itself, so we need to cancel out the 2. To do that, we'll divide this side by 2. And if we divide the right hand side by 2, we have to do the same to the left. So on the right hand side, 2 divided by 2 will cancel out. We'll just be left with or squared. On the left hand side, 32 divided by 2 will give us 16. To get to the final stage of answering this question, we need to get rid of the or squared, so we're just left with or. So to cancel out our square, we're going to get a square root. And again, what we do on the right hand side, we have to do on the left. On the right hand side, our square and our square root cancel out, so we're just left with or. On the left hand side, the square root of 16 gives us 4. Now, because this is an area and volume question, we need to think about what unit we're going to include for our answer. If we look back to the question, the area was given in meters squared, so in meters squared. So that means we're going to be using meters as our base unit here. In this case, the radius is a length, so we don't need to put any square or cube sign next to it. So this is our answer for radius, 4 meters. Now we'll have a look at the second part of this question when we need to calculate the volume of the hemisphere. So we'll go back to the question and we'll follow our 4 steps through again. Step 1 asks us to identify the shape, which is a hemisphere here again. Step 2 asks us to write out the question, or asks us to write out the formula that we're going to use. So we're trying to find volume here, so it makes good sense to use the formula for the volume of a hemisphere. When we write that formula out, we get 2 over 3 pi or cubed. Step 3 asks us to fill in what we already know. We don't know the volume because we're trying to find that. We're going to leave pi as it is because we're getting our answer in terms of pi, so we don't need to sub in a decimal. We know the radius from the last part is 4. Whenever we see the word hence, it just means using your answer to the last part. So we have to find the radius first in order to be able to do the hence part, which comes next. Now we'll go back to our step 3. So we're going to cube 4 afterwards. Now we go on to step 4. Step 4 is where we simplify this, try and solve out for our unknown variable. In this case, that's v, the volume. So we'll leave v as it is, 2 over 3 as it is, and pi as it is, because BIDMA says our first step here should be to do the indices. So 4 to the power of 3 gives us 64. Our next step, according to BIDMAS, should be to multiply. Pi is still going to stay as it is, but we can multiply 2/3 times 64. So if we put this into our calculator, 64 times 2/3 will give us 128 over 3 pi. You can give this answer as a decimal if you want either. It doesn't say to give it to a specific number of decimal places, so I'd probably choose just to include 2 as a default. I'm going to leave mine as a fraction though. The only thing I'm going to change is that I'm going to make this a mixed fraction, so the answer will be a little bit easier to understand. It really doesn't matter though what form you give it in for this question, because it doesn't ask for it as a fraction or a decimal. It just says to give your answer in terms of pi. So now we'll just look at the unit here. So volume is always measured in cubic units, and we said our base number provided in the, or base unit provided in the question was meters. So our unit that we're going to use here is also going to be meters, but for volume it's going to be cubed. So 42 2/3 times pi meters cubed. So now we're going to have a look at another question. It wants us to find the volume and surface area of a below shape, taking pi as being 22 over 7. So this is something we'll see commonly. Instead of being 3.14, they'll ask us to use a fraction that's kind of close to the true value of pi as well, 22 over 7. So again here, it's important to realize that we're being asked to do two things. And we have A, to find the volume, and B, to find the surface area. It's always a good idea to highlight that or to write it in next to it, so that, like I said before, when we finish part A, we don't forget about the second part here either. Now the shape we're given here is a mixture of a cylinder in the middle, then a hemisphere on each side. So that's going to be important in finding the volume and surface area. So that's basically our step 1 done. We have identified what the shape is. It's a cylinder with 2 hemispheres. Step 2 now, finding the volume, is going to be to write out the formula we can use. So what we're going to have to do is find the volume of a cylinder and add 2 times the volume of the hemisphere, because both of these hemispheres are identical. So we're going to add 2 times the volume of the hemisphere, giving us the volume of this part and this part. Added together to give us the volume as a total overall. Just using these small subscripts here, that's not something you have to do, but it can be a good way to keep track of things. So the volume T is total volume, volume C is the volume of the cylinder, volume H is the volume of the hemisphere. So now we're going to actually expand these out a little bit. So our total volume will be the volume of the cylinder, which is pi or squared H. Then we'll add 2 times the volume of the hemisphere, which is 2 over 3 pi or cubed. When we move on to step 3 and start filling in the variables we know, we get the following. I've written it all in one go to try and save in a bit of length on the video. So pi gets replaced with 22/7, the radius is 3 and the height is 10. 2 times the volume of the hemisphere, we're going to sub in 22/7 for pi and 3 for the radius. Next we move on to step 4, we're going to start solving this out. At this point, the amount of calculations you have to do is getting a bit more complex. So what we're going to do here is we're going to use Bidmas, but use our calculator to help us through it. Bidmas tells us that the first thing we should do is try and solve what's inside the bracket. Now, this bracket can't be simplified. 3 is 3, 10 is 10. 22/7 can't be simplified anymore. But this entire bracket here actually can be simplified first. So this is where our calculator comes in, and we can use that maybe to help us simplify the inside of this bracket here just a little bit. So if we keep the term on the left the same for now, then use our calculator to simplify the term on the right, we'll get 2 times 56.57. Now at this point we've gotten rid of any brackets that we can simplify altogether. So what we might do is try and simplify each of these terms, so our left term and our right term separately. Again, using our calculator if we're comfortable in doing that. So our left term will simplify to 282.86, remembering that the left term was the volume of the cylinder. And our right term will simplify to being 113.14. Now again, to get the total volume, what we're going to do is just add the two of them together. This gives us a total volume of 396. Now we want to find the unit as well. So the unit that we were already dealing with was centimeters. We're going to keep that. And then just remember that for volume, the units should be cubed. Now we'll look at the second part of this question where we're asked to calculate the total surface area of the shape. So again, the first step is always to identify the shape we're dealing with. Here we said it's a cylinder with 2 hemispheres. So to calculate the area, what we're going to have to do is calculate the curved surface area, not the total surface area of these shapes. So the curved surface area will be the curved surface area of a cylinder formula, ignoring the 2 flat ends because they're not actually counted in the outside area of the shape. For the hemispheres, we're going to also calculate the curved surface area because again, we're ignoring the flat circles which are actually in the inside of the shape in this case. So the formula that we're going to use is going to be the area, you can say the curved area for the cylinder and the curved area, so we have 2 of them, 2 times the curved area for a hemisphere. When we start filling that in and expanding out what those formulas actually are, the total area will be equal to curved area for a cylinder, which is 2 pi or h, plus 2 times the curved area for a hemisphere, the formula for which is 2 pi or squared. Now we can move on to stage 3. We start filling in what we already know. So our total area is going to be equal to 2 times 22/7, because they asked us to use pi as 22/7, times the radius, 3 times the height, 10, plus 2 times 2 times 22/7 times 3 squared. Going to use a different style of brackets along the outside here to differentiate from the outside brackets and the 2 inside ones. Again, when we move on to step 4 here, solving the equation out for unknown, the area, it can be a good idea to use BIDMAS to try and help us along our way. So BIDMAS says first of all we should always try and simplify brackets. These three cannot be simplified anymore. On the right hand side we have the square brackets what actually can. None of the brackets inside can, but the big square bracket can. So we're going to try and simplify this using our calculator. When we solve this out, we get 56.57. When you're doing something more complicated like this in your calculator that involves some fractions and some indices, it's pretty important to just make sure that you're looking at the calculator before you press the equal sign to make sure you've entered everything incorrectly, because this is somewhere that students can go wrong pretty frequently. Now again, we'll use our calculator to try and help us out with this. We're going to simplify the left hand side term and we're going to simplify the right hand side term and see what we get out. So when we multiply each of these terms out, on the left hand side we get 188.57. And this is the curved surface area of the cylinder. On the right hand side we get 113.14, which is the area of our two hemispheres. At least the outside curved area. And to get the final area all together, we're just going to add these two together. This gives us a total outside area of 231.71. Now we have to be careful again not to forget our units. Our units here were centimeters to begin with, and we know that for area it's squared. So we're going to get 231.71 centimeters squared. And that's our final answer.